Good day, guys. My name is Albert, and this is my channel, Einbert Electric. Today, I will discuss the very fundamentals of electrical system design, which is called branch circuit calculations. This topic episode is good for electrical enthusiasts, electrical engineering students, vocational, technical, electrical students, electricians, and electrical engineers. This is my very first video episode of a long series which I plan to create. So let's get started. What is a branch circuit? According to NEC, or the National Electrical Code, branch circuit is the circuit conductors between the final overcurrent device protecting the circuit and the outlets. So here, let us check how the branch circuit looks like. So this is our panel board, the final overcurrent device, circuit conductors, and the outlet, or usually it is a junction box or convenience outlet. So here it is clear what is a branch circuit. So how do we size the conductor for a branch circuit? We have here a given load, an electric storage tank water heater, which we will try to calculate. First, we will review the NEC rule. As a general rule, branch circuit conductors shall have an ampacity not less than the maximum load to be served. Conductors shall be sized to carry not less than the larger of 210.19A, 1A, or B. So that means there are two options. We have the option A and the option B. Let's check the option A. For option A, where a branch circuit supplies continuous loads or any combination of continuous and non-continuous loads, the minimum branch circuit conductors shall have an allowable ampacity of not less than the non-continuous load plus 1.5% of the continuous load. For option B, the minimum branch circuit conductor size shall have an allowable ampacity not less than the maximum load to be served after the application of any adjustment or correction factors. So here we have two options when we calculate the conductor size for branch circuit. Option A, we shall use the 125% times the continuous load plus 100% of the non-continuous load. And for option B, we shall use the adjustment and correction factors, which depends on the environmental conditions where the conductors will be installed. But first, let us discuss the exception to this code rule. The exception says that if the assembly, including the overcurrent devices protecting the branch circuit, is listed for operation at 100% of its rating, the allowable ampacity of the branch circuit conductor shall be permitted to be not less than the sum of the continuous load plus the non-continuous load. Let's just take an example. If the given circuit of heater assembly is listed to operate at 100%, so I of heater or current of heater, which is also equal to the current of a conductor, 4,500 watts, which is the capacity of our heater, divided by the input voltage, which is 240 volts. So the current that passes through the conductor is 18.75 ampere. Now, this is the current. From here, get the conductor size directly from the NEC conductor table. So we shall use 2 by 3.5 mm squared, or number 12 American wire gauge, TW, for example, stranded copper conductor. For those who don't know how to get this size from the table, so here later as we move on, you will understand how the table is used. Now let us start calculating for the option A. The given load details are: heater wattage is 4,500 watts. This heater is considered as a continuous load, so we have to support it. The supporting NEC provision is 422.13, which states that the water heater, which have a capacity of 150 liters or less, must be considered as continuous for the purpose of calculating branch circuit. The input voltage is 240 volts. Continuous load. What is the meaning of continuous load? A load where the maximum current is expected to continue for 3 hours or more. So here the heater actually is not a continuous load, because as we know, the heater switches on and off, and it will not work for 3 hours continuous. However, because of the NEC provision for 22.13, it is allowed just for the purpose of calculation for the branch circuit. Current that will be drawn by the heater, if connected to a voltage supply of 230 volts, so current of heater 4,500 watts divided by 230 volts. Current of heater is 19.56 ampere. This is the maximum load to be served. Applying the NEC rule, continuous load is 19.56 since we have only the heater, and the non-continuous load is 0. We don't have any other equipment or device considered as non-continuous load. So the same current will flow through the conductors. Therefore, option A as per NEC is current through the conductor is 19.56 times 1.25 plus 0, or I of the conductor is equals to 24.45 amperes. Now let us select from the conductor table in NEC below what standard size conductor have the ampacity of at least 24.45 ampere or more, depending on the application and other considerations. So we have here the conductor table. As we can see, 30 ampere is selected from the 60-degree column, and this corresponds to number 10 American wire gauge. and this is equivalent to 5.5 mm squared. So we have to select from the table number 10 American wire gauge, or equivalent to 5.5 mm squared, with a conductor ampacity of 30 ampere. Notice that 30 ampere conductor ampacity is more than enough to carry the calculated minimum required conductor ampacity as provided by the code in option A. Why the 60-degree column of the table was used? Why is it not 75-degree column or 90-degree column? This is because there is a separate code rule that explains on terminal connection or temperature limitations. For 60-degree column, use if circuit rating is equal or less than 100 ampere, and use 75-degree column if the circuit rating is greater than 100 ampere. What is a circuit rating? According to NEC, circuit rating means branch circuits recognized by this article shall be rated in accordance with the maximum permitted ampere rating or setting of the overcurrent device. The rating for other than individual branch circuits shall be 15, 20, 30, 40, and 50 amperes. Where conductors of higher ampacity are used for any reason, the ampere rating or setting of the specified overcurrent device shall determine the circuit rating. So what does it mean in simple explanation? That means that the branch circuit rating depends on the rating or setting of the overcurrent device, like a circuit breaker or a fuse. Now, what is the use of the 90-degree column? It can always be used provided that the conductor ampacity be based on the lower terminal temperature or conductor insulation rating. A separate topic on this will be discussed in my coming episodes to deeply discuss this code requirement. For now, let us follow and accept this rule. This option considers conditions that utilizes correction and adjustment factors. Now we are in option B. Correction factor or temperature correction factor in particular is used when the table values reference temperature differs from that of the actual ambient temperature where the conductors will be applied or installed. Adjustment factor is used if the circuit current carrying conductors exceeds 3 numbers, including spare conductors in a conduit or raceway or cable. Conductor's ampacity table in NEC is based on ambient temperature of 30 degrees centigrade or 86 degrees Fahrenheit. So let us make some assumptions for the conductors. Number one assumption for our option B, it will be installed in a location where the ambient temperature reaches 45 degrees centigrade. Take note that this is different from the table reference temperature. So one assumption is the cable will be installed in a location where the temperature reaches 45 degrees centigrade. So possibility is it will be installed outdoor, and this is in a desert location. Number 2, assumption. The circuit is two-phase, three-wire, with equipment grounding conductor, and it will be installed in a PVC conduit. So, how do we calculate? First, check the table for ambient temperature correction factor. Second, check the table for adjustment factor. Note that heater load current is, we have to take note of this, current of heater is 19.56. Also, conductor current 19.56. Now using the NEC tables for correction and adjustment factor, getting the ambient temperature correction factor. This is the table for ambient temperature correction factors, which is also based on 30 degrees centigrade. So using again the 60-degree column as specified by the National Electrical Code, for now we shall use the 60-degree column. Notice that for an ambient temperature of 41 to 45, you have to use 0.71 as a factor to be multiplied to the conductor ampacity in the table. And getting the adjustment factor, this is the table. This table tells that for more than 3 current carrying conductors, adjustment factors for more than 3 current carrying conductors. Our second assumption is only 3 current carrying conductors, so therefore we shall use the 100% factor here, because this table only derates if the conductors is 4 to 6 or more. Now let's do the calculation for the option B, and let us review the rule. The minimum branch circuit conductor shall have an allowable ampacity not less than the maximum to be served after the application of any adjustment or correction factors. So after the application of any adjustment or correction factors, so that means we have to apply the adjustment factor, we have to apply the correction factor, then derate the value of current. After that, we have to size up the conductor so that we can still recover the maximum load current which is required. So current on the heater is 4500 watts divided by 230. We have 19.56. This is the maximum load to be served. Also, conductor current is 19.56 ampere. For a quick calculation, let us calculate the total factor, which is the adjustment factor and the ambient temperature factor. So multiplying those two factors, we will get 0.71 total factor. We have to apply or multiply this factor to conductor ampacity in the table to quickly get value equal or greater than maximum load to be served of 19.56 ampere. Using again the same 60-degree column and using 30 ampere conductor ampacity, We multiply it by our total factor, 0.71, so we get 21.3 ampere. This is sufficient to carry the maximum load to be served of 19.56. At the same 60-degree column, let us try also 40 ampere as the conductor ampacity. Multiply it by our total factor, 0.71. We get 28.4 ampere. This is also sufficient to carry the maximum load to be served. So why do we calculate two options? This is because we don't know yet which conductor will match our overcurrent protection device, which later we will compute. So selecting from the conductor table in NEC, below under 60-degree column, which ampacity can retain the maximum load of 19.56 ampere. It shows that 30 ampere and 40 ampere both suffice for the maximum load. So as we can see here in this table, on the 60-degree column, 30 ampere and 40 ampere was selected, and both are sufficient to carry the maximum load. So now let us compare conductor sizing options, which is the option A and option B. For option A, again we calculate the maximum load to be served, which is usually 19.56 ampere. We multiply it by 1.25 as provided by the code, plus the non-continuous load, which is 0. Now we get current of conductor is 24.45 ampere. So from here, we'll use the table, and from the table, it shows that number 10 American wire gauge is sufficient with a 30 ampere ampacity. For option B, this is the maximum load to be served, the same, 19.56 ampere, and using the factors, adjustment factors and correction factor, at the same 60-degree column, using 30 ampere ampacity times the total factor of 0.71, it gives us 21.3. This is sufficient to carry the maximum load. And 30 ampere corresponds to number 10 American wire gauge. 40 ampere times total factor 0.71, that is equal to 28.4 ampere. This is also sufficient to carry the maximum load. And 40 ampere ampacity in the table corresponds to number 8 American wire gauge. Let us review the NEC rule for the branch circuit conductors. Sizing. Branch circuit conductors shall have an ampacity not less than the maximum load to be served. Conductors shall be sized to carry not less than the larger of A or B. So that means we have to do the trial calculation. We will do the option A first and then the option B. So whichever results into the larger conductor, that is the conductor that we shall use for the branch circuit conductor. In this case, it showed that option A and option B yielded the same conductor size. As we can see in the previous slide, Option A and option B have the same conductor size, which is number 10 American wire gauge or 5.5 mm squared. But which one will suffice and match the overcurrent protection device size or rating? The conductor size that must be used could be any one below. Two number 10 American wire gauge or 5.5 mm squared, which have a 30 ampere ampacity, either TW, THW or THSN, stranded copper conductor, or two number 8 American wire gauge, 8 mm squared, which have an ampacity of 40 ampere, TW, THW, THSN, stranded copper conductor. Why is it that TW, THW, THSN have the same ampacity? This is another special topic in one of my succeeding video episodes. So watch for it. Now let us remember the points when sizing the branch circuit conductors as per NEC. So number 1, we have to calculate the conductor size using option A, which uses 125% of continuous load plus 100% of non-continuous load. For number 2, calculate conductor size using option B. This utilizes uses the adjustment factor and the temperature correction factor. So we have to derate the value of ampacity. Then we have to check which conductor is sufficient to retain the maximum load requirement. And third, we have to decide whatever yields the largest conductor size, it shall be final conductor size to be used. And lastly, to specify the conductors properly, we have to use the quantity, number of sets, size, insulation, etc. For example, use 2 by 8.0 mm squared or 8 number 8 American wire gauge THSN stranded copper conductor. Overcurrent protection device or OCPD sizing calculation. Let us see the NEC rule for the sizing of overcurrent protection device. It says that continuous and non-continuous loads, where a branch circuit supplies continuous loads or any combination of continuous and non-continuous loads, the rating of the overcurrent device shall not be less than the non-continuous load plus 125% of the continuous load. So the sizing of overcurrent protection is similar to the option A of sizing the conductor size. It's just a 125% of continuous load plus 100% of non-continuous load. So here is our panel board, and this is our branch circuit breaker or OCPD or overcurrent protection device. Now let us apply the code rule for OCPD sizing. So we have to remember again the maximum load to be served for our heater load is 19.56. And applying the code rule, so current for the OCPD or overcurrent protection device is 19.56 times 1.25, or that is 125%. Because this is only a continuous load, we don't have the non-continuous load, so it is 0. Now current for OCPD is 24.45. Now this is the minimum value, which is the basis for the size or rating of the overcurrent protection device. So this is now our basis for selecting the circuit breaker or fuse, 24.45 ampere. From the table shown, get the nearest standard size and provide the specification. So from the table or from the standard rating of fuse and circuit breaker, we have to use 25 ampere trip, 2 pole, 10 kaik, MCCB, bolt-on type circuit breaker. This 10 kaik means 10K means 10,000 ampere interrupting capacity. So for those who is not yet familiar with this, later I will provide a video episode including these explanations. So this is the standard ampere ratings for fuses and inverse time circuit breakers from NEC. Note that we have to select 25 ampere trip circuit breaker. Why? Since 24.45 is the minimum, we cannot select the 20 ampere. Although this will protect the conductor, but the NEC says this is the minimum basis, 24.45. So we have to select the 25 ampere trip circuit breaker. Now let's check the matching of conductor ampacity and overcurrent protection device. We have the selected conductor size, which is number 10, American wire gauge or 5.5 mm squared, 30 ampere ampacity, TW stranded copper conductor. Note that this is in option A. We have a 24.45 ampere. For option B, conductor effective ampacity is 21.3 as previously calculated. For number 8, American wire gauge or 8 mm squared with a 40 ampere ampacity, TW. Effective conductor ampacity is 28.4 as previously calculated. This effective ampacity means this is taken from the table ampacity of the conductor multiplied by that correction and adjustment factors. That's why it is called effective ampacity, because it is already derated. So for 30 ampere, we have 21.3 only effective ampacity. For 40 ampere, we have 28.4 ampere effective ampacity. Now we have also selected our overcurrent protection device, which is 25 ampere, 2 pole, 10 kaik MCCB bolt-on type circuit breaker. Note that OCPD 24.45 is the minimum value basis for the size or rating of OCPD. So this is the minimum value. That's why we selected 25 ampere trip. Now let us check the matching. So for 30 ampere, 21.3 here compared to 25 ampere trip. So are these two values match? That is a question mark. And also 25 ampere trip, we compare it with a 28.4 for the number 8 American wire gauge conductor. So which one is matching? 25 ampere trip, 23, or 25 ampere trip and 28.4? So finally, we have to select number 8 American wire gauge or 8 mm squared with 40 ampere ampacity. This matches the OCPD. Why? Notice that 25 ampere trip is the theoretical ampere trip. It will trip at this value, 25 ampere trip. And notice that our cable ampacity is 28.4, which is higher than the value of the protection. So therefore, when our breaker trips, our conductor here still is not started heating. It will not heat up. While if we use the number 10 American wire gauge, before our breaker trips, notice that our conductor will heat up, or maybe it will be melted because it is lower than the value of our protection. So 25 ampere trip and 28.4 or number 8 American wire gauge conductor with 40 ampere ampacity is the correct size of matching conductor size and protection device rating. Now let us determine the equipment grounding conductor. In the branch circuit, this is also required to size the equipment grounding conductor. How do we size? As per the NAC, size of equipment grounding conductor, general rule, copper, aluminum, or copper-clad aluminum equipment grounding conductors of the wire type shall not be smaller than shown in table 250.122. So it is here shown, but we have to use the table 250.122. Minimum size equipment grounding conductor for grounding raceway and equipment. So how do we use this table? Remember that we have a 25 ampere trip breaker, and this column says rating or setting of automatic overcurrent device in circuit ahead of equipment not exceeding amperes. So 25 ampere exceeds 20, but 25 ampere does not exceed 60. So we have to use this column 60. And there we can get the copper conductor for the equipment grounding conductor number 10 American wire gauge or 5.5 mm squared. And now we have to select also the conduit size for the circuit. So now let us assume an EMT conduit which is appropriate for the installation. Whether it is PVC or EMT, the same procedure for using this table. Now this is the table of the EMT conduit, and as we can see, let us remember that our insulation selected is TW. And also we have three conductors. There are two number 8 and one number 10. But if we are going to use number 10 and number 8 here, we can never get the value of the conduit size. So let us assume instead of 2 number 8, since 8 is larger than 10, so let us make it 3. Let us make these 3 conductors number 8. So if you are using the table, we will use this 5 conductors because there are only 3. So if we use 2 here, it is not sufficient, it is not possible, so we will use 5 value here, and this correspond to 3/4 inch conduit or raceway, which is equivalent to 21 mm diameter. So now let us summarize our calculations for branch circuit. This is very important and this is complete calculation. Now this is our panel board where our branch circuit overcurrent protection device is being installed here. This is our load water heater. We have selected the 25 ampere trip 2-pole circuit breaker. This is our selected conductor, 2 by 8.0 mm squared TW stranded copper conductor. Our circuit is 2-phase 3-wire circuit. And this is our selected equipment grounding conductor, 1 by 5.5 mm squared or number 10 American wire gauge stranded copper conductor. And this is our conduit or raceway, which is 3/4 inch in diameter or 21 mm diameter, EMT conduit. If it is a PVC, the same procedure, you will go to the table and find a value or number of conductor which is more than 3 or exactly 3 because we have here 3-wire circuit. Thank you for listening. Thank you for watching. If you want to learn more with me, just like and subscribe to my channel, Einbert Electric, by clicking the bell. Thank you, and I hope you learned something. God bless.